Okay, so speaking of recordings, earlier this term, in the second term, we did quite a long course on trigonometry and trigonometry foundations. So we covered everything to do with the CAST diagram, all stations to Cape Town, basics of reduction, special angles, equations, all of that stuff we did. So if you do want to refresh or have another look at something or practice all that sort of grade 11, it's pretty much we did a thorough run through of all the grade 11 trigonometry. And we never got around to doing the grade 12 trigonometry. So that's why we are kicking off with compound and double angles, because all your trigonometry in grade 12 is basically grade 11 trigonometry plus compound and double angles. So everything you need to know for trigonometry, you would have learned in grade 11. And then, yeah, we did a proper run through of that a few weeks ago. So yeah, you can access those recordings if there's a specific topic that you want to revisit, if you want to maybe have another look at reductions, etc. It's all there, and you're welcome to get some popcorn and watch all of those lessons again. Okay, but what is a compound angle? Okay, so a compound angle is formed by adding and subtracting two angles. It's as simple as that. You make an angle by adding two angles together or by subtracting two angles. Now, there are 4 compound angle identities. Now, these compound angle identities are on your formula sheet, so you have no need to memorize them or anything like that. They're on your formula sheet, and where they come from, how they are derived, is not something that we're going to be covering in this course, but your textbook should have it, or your teacher at school might have gone through that already. We are just going to launch straight into using these identities, because that really is where the marks are. So these ones are on your formula sheet that you get with your exam. So you must make sure that you pick the right one and that you copy it down correctly from your formula sheet when you do work with it. Okay, so the compound angle identities work 2 ways. We can expand. We can use the identities to expand a trig ratio of a compound angle, or we can use it to contract it. Okay, and that's basically the 2 options. The 2 things that you do with the compound angles. You're either expanding or contracting. How does it work? Okay, so here's sine x plus y. And straight away, I just want to kind of remind you that sine x plus y is not sine x plus sine y. We don't distribute the sine or the cos into the bracket with the angle. No, because we have a compound angle identity for it. Okay, so sine x plus y, you can see, goes with this one here, sine a plus b. So we are going to expand it and use that identity to do it. Okay, so sine x plus y, we use that first one. We're going to go sine x cos y plus cos x sine y. Okay, and that's it. We are just expanding. Cos alpha plus 10. Cos alpha plus 10, we look for the compound angle identity. That's where it's cos and 2 angles are added together, and that's this one here. So we can just go cos alpha cos 10 minus sine alpha sine 10, because we are literally just writing it into our identity. Okay, I want you to do the next one on your own. Cos x plus 60. And as soon as you have an answer, pop it in the chat. Let's see how everyone is doing with their compound angles. I'm going to give you 30 seconds for this. Cos x plus 60. Nice. Liam, Sibusiso, well done. Please pop it in the chat and make sure that you send it to everyone. Okay, I see it. It's coming directly to me, and it would be nice if we can post it to everyone in the chat. So how you can do that is where it says to as you are typing your message, just change my name to where it says everyone. There we go. Mr. Lucky has posted the instruction there as well. Please send to everyone. Use the drop down next to two. That will make sure that everyone in the meeting can see the answers. Okay, right. But that's correct so far. We are going to use cos A plus B to expand this. So that is, okay, Cassandra says she can't change hers. I'm wondering if it is a setting in the background, maybe. Everyone doesn't appear on mine. Okay. Okay, guys, so just hold on. I think we should be able to fix it. Because we do want everyone to be able to see each other's answers. I'm just going to go quickly. Hang 10 so long, go on to D, and we're going to try and fix this chat setting quickly.
Yeah, I think I fixed it.
Did you fix it? Thank you so much. Please try again, guys. See if you can message everyone. Awesome. There we go. Thanks, Mr. Lucky. Okay.
Ma'am.
Okay, guys, so just now make sure that where it says to in that drop down that you select everyone, because I'm still getting quite a few direct messages. It's lovely, you can message me, but if it's intended for everyone, just make sure. There we go, there's some answers coming through. Excellent. So sine 3x minus 45, we are going to use this identity, sine A minus B, and we're going to write sine 3x cos 45 minus cos 3x sine 45. Okay, so now what we notice here is that we in fact have a special angle, 45. So if we have a special angle, we need to use our special angle ratios to simplify that further. So if you got this far, now your next step is going to be to change your cos 45 using your special angle triangles. I wonder who can remember. You all just wrote exams, so I'm sure you guys can remember your special angle triangles. 45, 1, 1, root 2. Remember, no calculator when it comes to special angles. And then we also have 60 and 30. Across from the 60 is root 3, 2, and 1. Okay, so we're going to leave sine 3x. Nothing we can do there. We can just go sine 3x. But cos 45, we can change to 1 over root 2. And then cos 3x, we can't simplify further either. But sine 45, we can change that to 1 over root 2. So that ratio you just get from doing opposite over hypotenuse for 45 degrees, and then for cos it's adjacent over hypotenuse. Okay, so yeah, that's basically it. We can do sine 3x, and we're timesing it by 1 over root 2, so that's going to be over root 2 minus cos 3x over root 2. And then the best we can do here is just put it all over the root 2, because that's the same denominator for both. So we have sine 3x cos 3x over root 2. Okay, do we need to go back to C? Yes, there we go. Let's just go back to C and finish that one, because 60 is also a special angle. Thank you for that, Mohammed. So let's simplify that. So cos x, and then cos 60, is adjacent over hypotenuse, so that's 1 over 2. And then sine x, sine of 60 is opposite over adjacent, so that's root 3 over 2. Okay, so it's not really making anything that much more simple. We just have cos x minus root 3 sine x, and we'll put it all over the denominator too. Okay, can I just see, put an emoji in the chat, how this is, a thumbs up or a thumbs down, to see how you are doing with expanding compound angle identities. Liam is giving me a thumbs up. Solomon says it's cool. Well done, Kolofelo and Tamika. Excellent, everybody. Whilst the root 3 in front, remember we can move it because it's multiplication. It's like 5 times 3 is the same as 3 times 5. So sine x times root 3 is the same as root 3 times sine x. Okay, wonderful, everybody. So like we said, we can expand and we can also contract. So for this next round of trig expressions, we're going to use our compound angle identities to contract. Okay, so let's see, cos alpha, cos beta, plus sine alpha, sine beta. That fits into which one of our compound angle identities? We've got cos cos plus sine sine, cos cos plus sine sine. That is going to be this first one. Okay, look carefully, Mpilo. We do have a plus between the two terms, which will make it cos A minus B. Okay, so it's this first one here. So we can rewrite this as cos alpha minus beta. Okay, do the next one. Sine x cos 40 plus cos x sine 40. Which one is that going to be? Have a look at your identities. Look for the pattern. Sine cos plus cos sine. Sine cos plus cos sine. Put it in the chat. Thanks for that, Mr. Lucky. That's very good, yeah. Cos, change sign, sine, same sign. Not confusing at all. Sine x plus 40, I agree. Well done, everybody. Sine x plus 40. Okay, well done. You're on fire this evening. Okay, last one for this round. Cos 2x sine 3x minus sine 2x cos 3x. Which one is it going to be? Cos sine minus sine cos. Cos sine minus sine cos. Look again, Liam. Cos sine minus sine cos. Cos sine minus sine cos. That's it. It's sine A minus B. A little bit of a catch there with the order of the terms, but it is sine 3x minus 2x. Okay, so if we put them into the right order, then it is sine 3x cos 2x minus cos 3x sine 2x. Okay, so that's it, guys. So that's the first sort of little glitch you can hit sometimes, is that you have to look so carefully, because sometimes they just change something around, which makes it look like one of the other identities. So make sure that you check very carefully which one it is, and that the pattern, that you follow the pattern correctly. So this we can still simplify, because 3x minus 2x can go down to just x. Okay, so if you want to write a note there for yourself, look carefully at, because here the terms were swapped around. Okay, a little bit more practice. Let's do those first two. Expand the following. Okay, and if you have a special angle, please simplify as far as possible using the special angle ratios. Okay, I'm going to give you 3 minutes to do these two. So we'll check back at 1723. Okay, we've got some answers already for cos A, alpha plus 70. So that's cos A plus B. So we're going to write that as cos alpha cos 70 minus sine alpha sine 70. Good. And then Primrose has given us the answer for sine x minus 45. Remember Primrose, we just want to expand, simplify it as far as possible because we've got cos 45 and sine 45, which is a special angle. So sine x minus 45, sine A minus B. So we're going to go sine x cos 45 minus cos 45 sine x. Okay, and then cos 45, I think we just had cos 45, didn't we? Oh, we had 60. Oh, yeah, and these are 45. So we use our 45-degree angle. So that's 2 root 2, 1 and 1. So sine cos of 45 is adjacent over hypotenuse minus cos 45 is adjacent over hypotenuse again. Sine 6 sine x. Hold on, I think I might have made a mistake here. So it's sine x minus 45 is sine x cos 45 minus cos x sine 45. Yeah, I think that's better now. Yeah, that's better. So I'm just reading some of your chat messages. Yes, thanks, Lesedi. I did fix it now. Let me just finish and fix the rest of it as well. Yeah, so now it's cos x and sine 45, which is opposite over hypotenuse. Okay, so I see that there's a question here about rationalizing the denominator. You don't have to, unless you are told to. It's not really necessary. We can leave this as cos x over root 2. If you were to rationalize the denominator, you times by root 2 times root 2, and we times by root 2 because rationalizing it means taking the root away, basically. So you can do it. For those of you who are wondering, this is what it will be. Root 2 sine x minus root 2 cos x over 2. But it's not a must. Okay. Right, where are we? Okay, so I see some of you have gotten started on question 2. Well done. Write the following as a single trig ratio. So single trig ratio for this one, we've got cos 14 cos sine plus cos sine. There we go. Cos sine, cos sine. What's wrong, Primrose? You say you're confused. So just type a question and then I'll be able to help you. Because if you're confused, then I'm not sure where we lost you. So just type a question, then it's easier for me to assist you. Okay, so cos 14, sine 6. Okay, let's give everyone a chance to do the next two, question 2a and question 2b. If you're confused about the denominator, rationalizing the denominator part, Primrose, it's just something that someone asked in the chat, and you rationalize the denominator by basically timesing the root 2 by itself. But when you do it at the bottom, you have to do it at the top as well. So that's why we times, like where I wrote here in blue, I times by root 2. No, you do not have to do it. I put it up for those who want to do it or can do it or asked about it, so that's what you need to do. You don't have to do it. Okay, so back to question 2a and b. Pop it in the chat so we can see your answers. Okay, while everyone's working on that, I see Sinavuyo's got their hand up. Please go ahead, Sinavuyo, and ask your question. Sinavuyo, you have your hand up, so you can unmute yourself and ask your question.
Well, on question 1. Question 1, number B.
Yes.
Well, on the second step.
Yes.
I say like sine x and like where here. Okay. Please explain the second step for me.
Okay, so we just take the cos 45 because it is a special angle, and we use our special angle to write it as 1 over root 2. That's what we did. And then the sine 45 is also 1 over root 2. That's a special angle. If you're not sure of your special angles, we did a whole lesson on that not too long ago. That's in our recording, so you're welcome to go back and have a look at special angles. Right, so we got, thanks Sinavuyo for your question. We are back to question 2a. So Sliabona, you say that 2a is sine 20. I agree, quite a few of you got that already. We go sine 14 plus 6 because it follows that pattern. It's 14 plus 6 and it's cos sine, cos sine. Remember the identities got it as sine cos, cos sine. So the first two terms, it's fine if you switch them around to actually fit the pattern, but it really is just sine 14 plus 6, and that is sine 20. 20 is not a special angle, so we don't need to simplify further. Then question B is cos theta, cos 4 theta minus sine theta, sine 4 theta. So it follows the pattern of cos cos minus sine sine, which gives me cos A plus B. That's the pattern for that one. So it's theta plus 4 theta, and that is cos 5 theta. Okay, so praise. There's a few of you who got the got it right, but simplify what is in the bracket. I think Mr. Lucky also said to you guys that you must simplify the like terms. Okay, so remember to do that if you can, if there are like terms that you can add. Okay. Do we always simplify it? If you can, yes, you do. Okay, so let's go on to this question here, cos of 75. So the question says, calculate the values of the following without the use of a calculator. Now, immediately when you hear without the use of a calculator, especially for you guys who were here when we did the Trig Foundations course, you need to think special angles. Special angles, 30, 45, 60. Those are our special angles. Also 90, 90, 180, 360, etc. So all the multiples of 90 are special angles as well. But for now, we're just going to kind of focus on using our special angles, 30, 45, 60. Okay. So you need to, for special angles, know your special angle triangles. That's where the ratio comes from, because it says that there without the use of a calculator. So if you do this with a calculator, you get no marks. Okay, they're very strict at the end of the year with this. So you have to only use your triangles. So let's draw them one more time. These must be completely like second nature to you already, because you've been doing them since grade 11. So that's 45. Remember, they're 90-degree triangles. 45, 60. So the way you can remember the 60 is that the root 3 is always across from the 60. 2 is the longer side, and 1 is the leftover side that we place across from the 30. Okay. So we've got that. Special angles. Why? Because it says without the use of a calculator. Now, obviously, 75 is not a special angle, but we can make a plan to write it as a compound angle using special angles. And I'm sure you guys can spot it already, that 30 plus 45 gives me 75. So use your special angles to write this angle as a compound angle. Remember, compound meaning add or subtract two angles. So 30 plus 45. That is going to give you cos 75. And for this, we can now use our compound angle identity to expand it. So cos 30 plus 45, that is cos A plus B. So you just go to your formula sheet, you look up your identity, and you expand it. Okay, so this is going to be cos 30, cos 45, minus sine 30, sine 45. Okay. So cos of 30, now we go to our special angle triangle, and we find the ratio for cos 30 adjacent over hypotenuse. So that is going to be root 3 over 2. Cos 45, we've already had this evening a few times, so adjacent over hypotenuse, so that's 1 over root 2. Sine of 30 is opposite over hypotenuse, so it's 1 over 2. And then sine 45 is opposite over hypotenuse, which is 1 over root 2. Okay, so here we can, let's multiply this together. So root 3 times 1 gives me root 3. 2 times root 2 is just 2 root 2. And then minus 1 times 1 is 1. 2 times root 2 is 2 root 2. So all we've done is we've multiplied the numerators together and the denominators together. Numerator with numerator, denominator with denominator. And now we actually get two fractions with the same denominator. So we can put them over 1. 2 root 2. Okay, and then some of you are probably wondering if we need to rationalize the denominator. You can do it, or you can leave it as is. Okay, let's see in the chat, because this is a popular question where they give you an angle and you have to use compound angles to special angles to write the angle as a compound angle. Okay, so let's see, just put an emoji in the chat, thumbs up, thumbs down. How are we doing with this question? Good, excellent. Okay, right. Good stuff, everybody. Right, so we're gonna leave the compound angles for now and just move on so that we do get it done this evening, the double angles. Okay, so if a compound angle is adding and subtracting two angles, then the double angle is adding this same angle to itself. Okay, so double angles are all about the same. Okay, now for the double angles, there's one expansion for sine of 2a, which is this one here. Sine of 2a is 2 sine a cos a, but cos 2a's got three different expansions. Okay, so cos of 2a can be cos squared minus sine squared. It can be 2 cos squared a minus 1, or it can be 1 minus 2 sine squared a. Okay, so those are the three different ones. And the trickiest part is probably knowing which one to use for cos of 2a. But if you practice lots and if you work through a lot of past papers, you will get the hang of it. Okay. So just like with the compound angles, we can use the double angle identities to expand. And then we can use the double angle identities also to contract. Okay. So let's have a look at this first one. Simplify. We've got sine of 2 theta. So sine of 2 theta. Immediately we must see the 2. So anything that's a double, like a 2 theta, 4 theta, anything that can be doubled, basically all the even numbers, you must immediately think double angle. You can most certainly take a screenshot, Kirsten. I'll leave it there for 10 seconds. Okay. Now let's go back to sine 2 theta. So sine 2 theta, we expand to 2 sine theta cos theta over sine theta. And that cancels out nicely. Sine theta divided by sine theta, that is just 1. And we've got 2 cos theta as our final answer. Okay, so now this next one, already we can see there's more than one way that we can expand cos to theta. Now, our choice is going to depend on the question and what will help us simplify the question. So if we look, we've got cos theta minus sine theta in this denominator. So our options are to do cos squared minus sine squared, 1 minus 2 sine squared, or 2 cos squared minus 1. So the one that is probably going to work best in order to simplify this expression is cos squared alpha minus sine squared alpha. Now, how are we going to go further from here? Well, we need to factorize this. Cos squared alpha minus sine squared alpha is a difference of two squares. Difference of two squares. So we can factorize it. Okay, so cos alpha minus sine alpha. That's how we're going to factorize it. Cos alpha plus sine alpha. Remember a difference of squares for those of you who might be rusty or haven't done factorizing in a while. A squared minus b squared is a difference of squares, and we can factorize it as a minus b, a plus b. Okay, and this is all over cos alpha minus sine alpha. And because that whole denominator is the same as a whole one of these brackets, we can cancel or divide them. And we are left with cos alpha plus sine alpha. Okay. Mohammed, you got that? Well done. That is exactly right. Okay. Right, we've got a few more minutes for practicing our double angles. So let's do C. Take 2 minutes now to do question C. Think carefully about your choice when you expand cos 2a. You've got those three options. You want the option that is going to help you to simplify the expression. Okay, give it a go. Lesedi, because the cos alpha minus sine alpha, it's remember that whole bracket is the same as the whole denominator. That is why we can divide it. Mohammed, looks like you are Speedy Gonzalez this evening, so please go ahead and do D as well. Sipusiso says it's cos A. Okay, 1 more minute and we're going to see. There's a few people on fire this evening. Okay, so cos 2a plus 1. You might have tried, if you tried sine, didn't really go anywhere. You can't really simplify very much. Cos squared minus sine squared also wouldn't have given you much to work with. So cos 2a minus 1, that was your best option. And it's your best option because minus 1 plus 1, that adds up to 0. And then we're left with 2 cos squared A over 2 cos A. 2's go. Cos squared divided by cos A, that's just going to be cos A. Okay, well done. I see a few of you praise. Kirsten, Liabona. Well done. You all got that. All right, we are going to call it a night over there, and we'll pick it up again on Thursday. Mr. Lucky, I think you are running a poll this evening. And then well done, everyone. Thank you. Thanks for your hard work this evening.